Welcome students. We are back with another lesson. In this lesson we'll derive the kinematic equations using a graphical method. So first let's derive our velocity time relation for a uniformly accelerated motion using our velocity time graph. Now before we start with this one, let us take a quick look into your velocity time graph. So we know in a graph there is a horizontal line which is your x-axis and there is a vertical line which is your y-axis. Now we will plot the information of velocity and time on this graph. So to plot the velocity time, on the x-axis I will plot time and on the y-axis I will plot the velocity. Now let us consider the journey for Alice. Now Alice begins with a zero velocity. So she is standing still at a zero velocity. Now what she will do, she will start her journey. She will start to slowly increase her speed with the time. Now as she increases her speed, can you see this white line? It denotes that she is walking with the increasing speed. It increases the speed up till it reaches to a certain point. After reaching to this certain point, what happens? She maintains a constant speed. That means she's walking at a normal speed. Now as soon as she's about to reach her journey ends, what she will do, she'll start to slow down. So this falling curve is representing her decrease in the velocity. So first the Alice started to increase her velocity. She started walking fast when she started her journey. Now at the intermediate stage, what happened? She maintained her constant speed. So you see this straight graph, uniform graph. Now as soon as she was about to reach her journey, she started to slow down and you see this negative steep slope. This represents her decrease in the velocity to zero. Now the velocity decreases, this final velocity will become zero when she reaches her destination. So this is an example of a velocity time graph where you see three different types of velocity. In the first case, you saw Alice was walking with a increasing velocity, a positive velocity. In the second case, you saw Alice was walking with a constant velocity. In third case, you saw Alice was walking with the decreasing velocity. Clear? So in this case, the velocity is positive. For the second case, the velocity is constant, and for the third case, the velocity becomes negative. Why? Because she is decreasing her speed. As you can see, because of a decreasing in speed, you see a down slope. Clear? Coming back, now let's derive this kinematic equation. So consider an object. The object is moving in a straight line with the initial velocity small u. Clear? So let us suppose the velocity, instead of starting from 0, it is starting with some velocity u. Clear? That's why it is starting from this point. Clear? So a body moving in a straight line with the initial velocity u and uniform acceleration, that means it is moving at a constant acceleration rate. Now while it moves in this velocity u, what happens? It covers some distance. That distance is represented as s and the time interval is represented with t. So this is the velocity time graph. So the object starts to move with the initial velocity u in some time interval. In this time interval, it changes its velocity from u to some velocity, let us say v at this point. Okay, so from this figure what we can gather, this point, okay, this represents your initial velocity u. Similarly, this ed distance, can you see this one? This one will see ed is also equals to oa, which will also represents your initial velocity u. Fine. Now what happens? The body starts to move and it increases its velocity. Okay, can you see? The body has increased its velocity. So let us say at this point, the velocity of the body is small v. Fine. So your distance EB represents your final velocity small v. Again, this distance EB is also equals to OC. Yeah. So this distance also represents your final velocity small v. Fine. Now here, this part, okay, this OE, it represents your time. 0 to t means how much time it takes, t time interval. Similarly, AD also represents your time interval t. Fine. So we know the acceleration formula is change in velocity upon the time interval. So what is your initial velocity? Small u. What is your final velocity? Small v. So what will be the change in velocity? It will be v minus u. Fine. So the change in velocity will be your final velocity v minus your initial velocity small u. So if you look in this figure, what is your final velocity? It is represented by OB. Fine. And what is your final velocity? It is represented by EB. What is your initial velocity? Your initial velocity is represented with ED. Fine. So the change in velocity will be v minus u, or I can also write EB, this distance, minus ED, this distance. So this part, yeah, this part dB represents your change in velocity. So instead of writing EB and ED, I can write dB. And your time interval is represented by this distance OE. Clear? So if you see carefully, the change in velocity is represented by this slope, which I have just shown using this video. So I can also write this change in velocity as, so the change in velocity per unit time, which is your acceleration, can be represented by this slope. Fine. And this slope can be written as dB upon OE. Fine. So your acceleration can be written as dB upon OA. Okay. Now what is your dB? dB represents the difference between EB and your ED. Okay, I will just write it down in case you forget. Fine. So in this case, what is your EB? EB represents your final velocity V. And what is your ED? ED represents your initial velocity small u. Fine. And similarly, your OE represents the time interval small t. Fine. Now what I can do, I can cross multiply this t on the other hand side. Okay. So if I simplify, I can write this equation as AT equals to V minus U. Okay. On further simplification, what I can do, I can write this one on this side of the equation, AT on the other side of the equation. Fine. Now I can send this initial velocity u to the other side. So I have my first kinematic equation. This is your velocity time relation. Your final velocity v equals to the initial velocity u plus the product of the acceleration, the constant acceleration multiplied with time. Fine. Fine. So this is your first kinematic equation. Similarly, we will derive the other two kinematic equation using the same graphical method. Okay. So that's it for today's class. And if you have any confusion or any doubt, please feel free to ask. I will re-explain it to you again. So that's it for today's class. Thank you.